Good morning. This lesson is for my Integrated 1 classes and my Honors Integrated 1 classes. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. And our first and only goal is going to be to solve linear systems of inequalities. And let's just review here really quick. The solution to an inequality is any point in the shading or on the solid line. The solution to a system of linear inequalities is any point where the shading overlaps. So to put it in just basic everyday terms, what we're going to do is we're going to graph two inequalities on the same graph, and we want to see where the shading overlaps. Where the shading overlaps, that's where we have a solution to both inequalities. You might want to write this down in your own words. That will also help you understand it better if you're able to explain it to yourself in simpler terms and not so mathematically. I also have a couple, little bit of review as well with the rules for shading. Shading rules for inequalities in slope-intercept form and why only inequalities. I should put inequalities, oh well. If I have this symbol or this symbol, I'm going to shade below. If I have this symbol or this symbol, I'm going to shade above. If I have this symbol or this symbol, my line is dashed, which means the solution is not on that. And if I have this symbol or this symbol, my line is solid. I have solutions there. It's in bounds to the solution. I also have shading rules for X-only inequalities. If I have this symbol or this symbol, I'm going to shade to the left of. If I have this symbol or this symbol, I'm going to shade to the right of. If I have this symbol or this symbol, my line is dashed. And if I have this symbol or this symbol, my line is solid. Now, hopefully you can understand what type of line an X-only line is based on how I'm going to shade it. And if not, you'll figure it out here shortly. All right, so I have three examples. I have an example in slope-intercept form, single variable, and standard form. So I'd like to just show you how to solve each of these, okay? So this first one is slope-intercept form. Squeaky pen. And I'm going to graph them in two different colors. Okay, so my first inequality, my M is 3 over 1, and my B is -4. So B is -4. I begin at -4, and I move -3 over 1. Remember, it's rise over run. So if I'm rising in the negative direction, I'm rising down. And if I'm running in the positive direction, I'm running to the right. So let's see here. I begin at -4. 1, 2, 3, 4. Oh no, I'm going to go off my graph with this. So I can rewrite this as a 3, and I hope you can see this, over a 1. I don't know if you can. You try to look at the red marker. A 3 over 1. Should have tried the markers before I taught this, huh? A 3 over a -1, which means I rise up 3 and I run left 3. All right. So 1, 2, 3, left 1. And again, if you're going to go off the graph and the negatives up top, put it below. I have my 2 points. Let's look at the symbol I have. I have a slope-intercept form. I have the symbol. So I'm going to shade above, and my line is dashed. Make sure you have the dashed line here. And I'm going to shade above. Okay, my red markers look to be done. Okay, so no more red markers, or those red markers. Let's do the other one in green. Y is less than or equal to 1/2 x plus 0. Here I had a hidden number there. And just to further stress, I had a hidden number there. All right, my B in this problem is 0. My M is 1 over 2, so I'm going to go up 1 and I'm going to run 2. I begin at 0, up 1, run 2. Let's go see what our inequality symbol says. I have this symbol, so I'm going to shade below, and my line is solid. So I have a solid line, and I'm going to shade below. Okay, so remember, we're looking for where the graphs overlap, the shading overlaps. And so what that means is my solution to this inequality is going to be bordered by this dashed line, this solid line, and all the shading that is overlapping. So if I was to pick any point in here, it would be a solution to both of these. If I was to pick a point here, it would be a solution to this. And if I was to pick a point here, it would be a solution to that. But where they overlap is a solution to both. Okay, it's a solution to both. If I pick a point on this dashed line, it is a solution to the top. No. It is not a solution to the top, but it's a solution to the bottom, right? Because the top has the dashed line. All right. So example number 2. Let's see if I got 2 different color markers to make this stand out. I'll try the purple one. I have a single variable inequality, so I'm going to graph that by making 2 ordered pairs. Let's see here. And my y value is always 4, so I can go 1 and 4, and I can go 3 and 4. 1 and 4 and 3 and 4. 1 and 4. Do that. And 3 and 4. Okay. This is a y only inequality, so I have to follow these rules. I have this symbol, so I'm going to shade below, and I'm going to have a solid line. Shade below and have a solid line. Now again, notice I'm not shading like crazy, because if you do that, it's hard to tell where the shading overlaps. All right. Second inequality. I'll write a lot. Second inequality. I'll do in green. Here I have an x only, so again, I'm going to make ordered pairs. My x value is always -2. So I can say it's -2 and 1, and -2 and 3. -2 and 1, -2 and 3. I have this symbol for my x only inequality, so I'm going to shade to the right, and my line is dashed. I'm going to shade to the right. So again, I want to stress that the answer is where the shading overlaps, and the answer to this system of inequalities is going to be bordered by this dashed line, this solid line, and any point in here. All right. So again, if I was to pick a point in the shading, it would be a solution to both. If I was to pick a point in the green shading, it would only be a solution to the x only, and if I was to pick a point in the purple shading, it would be to the y only. So we got one more example, and when I was grading your guys' tests and quizzes, you guys really did struggle with turning standard form into slope-intercept form. So again, pay attention to how I do this, and before I move on, this example was single variable, right? Squeaky. Let's try this marker. This last example is going to be standard form. And again, you guys did have a problem solving this, but you have the steps hopefully written down on your cheat sheet, and hopefully you're following this. All right, so I'm going to convert this one into slope-intercept form, and remember on your cheat sheet it says add or subtract the ax to the other side, and then divide everybody by the b value, and then follow the shading rules. Okay, but and one more thing, if we divide by a negative, we have to flip the inequality symbol. All right, so we'll do this one in green. I have x plus 2y is left of left of 6. I'm going to put a 1 with that because it's 1x. It's a positive 1x, so I need to subtract it. Minus 1x. That cancels out. I get 2y is left of minus 1x plus 6. We divide everybody by 2. And we get y is left of, or below, negative 1 over 2x plus 3. Okay, my b on this problem is 3. My m is negative 1 over 2, so I'm going to rise down and I'm going to run to the right. So I begin at 3, 1, 2, 3. I rise down 1 and I run 2 to the right. Let's look at what this says about that symbol. I'm going to shade below and my line is dashed. I'm going to shade below. Make sure I'm still on the screen here. I really hate having to re-record these. It gets really old. Oh, I got plenty of space. Plenty of space. All right. Next one. Next one here. I did green. Let's see how this purple one looks. Okay. So here I have 3x minus y is left or below or at 4, less than or equal to 4. So again, I'm going to start by adding and subtracting the ax value to the other side, and I get negative y is less than or equal to minus 3x plus 4. You know, I'm going to put a plus or a minus 1y there. Minus 1y. The next step is divide everybody by the b value. Now, we're dividing by a negative, so we must flip this. So we're going to divide everybody by a negative, and I hope you can read these numbers. Y, I flipped it because I divided by a negative, and negative makes a positive. 3 over 1, x minus a 4. Here our b is a negative 4. Our m, this is super squeaky, is 3 over 1. So I'm going to rise 3, run 1. All right, I begin at negative 4. 1, 2, 3, 4. I'm going to rise 3. 1, 2, 3, run 1. Let's see what this says about our line. I have this symbol, so I'm going to shade above, and my line, I'm going to shade above, and my line is solid. Okay, I'm going to shade above, and my line is solid. So shade above. Okay. So again, I'd like to highlight this answer where the shading overlaps. This is bordered, the solution is bordered by this solid line, that dashed line, and all the points in here. All right. So again, we saw systems in slope-intercept form, single variable, and standard form, which is when you guys are struggling with this, and hopefully seeing it again and again helps you. I hope that we can see this clearly. I do apologize if it's a little faint. And remember, the point of this lesson was to find where the shading overlaps. That's really the answer, because that's going to be a solution to both. All right, so I'm going to go ahead and end this one here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.